What if the future of computing isn't about doing everything, but doing one thing brilliantly? In a world obsessed with speed, scale, and intelligence, application-specific semiconductors are quietly becoming the backbone of digital transformation. These aren't your everyday chips. They're precision engineered to accelerate artificial intelligence, power autonomous vehicles, and optimize everything from wearable health tech to smart infrastructure. And while they may not grab headlines like flashy gadgets or viral apps, they're shaping the very architecture of tomorrow's intelligent systems. In this episode, we explore how application-specific semiconductors are redefining performance, efficiency, and strategic control across industries. From AI accelerators to mission-critical defense processors, we'll unpack why purpose-built silicon is the new frontier, and why it matters for leaders, engineers, and educators alike. Welcome to The Digital Revolution with Jim Kunkel, where we decode the technologies driving legacy, resilience, and global impact. Setting the stage, what are application-specific semiconductors? In the world of computing, not all chips are created equal. While general-purpose processors like CPUs are built to handle a wide range of tasks, application-specific semiconductors are engineered with laser focus. These chips are optimized for one job, and they do it exceptionally well. Whether it's accelerating artificial intelligence, powering autonomous vehicles, or enabling real-time diagnostics in wearable tech, application-specific semiconductors are the silent workhorses behind today's most advanced systems. Think of them as the difference between a Swiss Army knife and a surgical scalpel. General-purpose chips offer flexibility, but application-specific semiconductors deliver precision, speed, and energy efficiency tailored to specific use cases. From Google's tensor processing units to custom chips in electric vehicles and industrial Internet of Things sensors, these semiconductors are reshaping how we think about performance and purpose. And as digital transformation demands more specialized intelligence at the edge, application-specific semiconductors are becoming the backbone of innovation across industries, where application-specific semiconductors are changing the game. Application-specific semiconductors are no longer niche. They're the strategic engines behind today's most demanding technologies. In artificial intelligence, custom chips like Google's tensor processing units and NVIDIA's AI accelerators are purpose-built to handle neural network workloads with blazing speed and energy efficiency. These chips don't just process data, they optimize learning, inference, and decision-making at scale. That's why they're powering everything from real-time language translation to autonomous drone navigation. In the automotive world, application-specific semiconductors are the brains behind autonomous vehicles. They fuse sensor data, manage safety protocols, and make split-second decisions, all while operating in harsh environments. In healthcare, edge AI chips embedded in wearables and diagnostic tools are enabling real-time monitoring and predictive analytics, transforming patient care. Industrial Internet of Things systems rely on low-power, application-specific semiconductors to drive predictive maintenance and smart infrastructure, while defense and aerospace sectors deploy mission-specific processors for secure, high-performance operations. These chips aren't just changing the game, they're rewriting the rules of speed, trust, and specialization. Global impact and supply chain shifts. Application-specific semiconductors aren't just reshaping technology, they're redrawing the global map of innovation and influence. As industries demand more tailored performance, countries are racing to secure chip sovereignty. The US, EU, and Asia are investing billions into semiconductor ecosystems, from fabless design hubs to advanced foundries. These chips power everything from AI to defense systems, making them strategic assets, not just technical components. And with rising geopolitical tensions, the ability to design and manufacture application-specific semiconductors domestically is now a matter of national resilience. But the supply chain is complex and fragile. From rare earth materials to ultra-clean fabrication environments, every step requires precision and coordination. Disruptions in one region can ripple across industries worldwide. That's why companies are rethinking partnerships, diversifying suppliers, and investing in vertical integration. The rise of custom silicon also means tighter collaboration between hardware engineers, software developers, and domain experts. It's no longer just about making chips, it's about aligning them with mission-critical goals. In this new landscape, strategic clarity and cross-border agility are the keys to staying competitive. Risk, ethics, and sustainability. As application-specific semiconductors become embedded in everything from AI systems to life-critical infrastructure, the stakes around risk and ethics grow exponentially. These chips aren't just technical components, they're decision makers. When a custom processor powers an autonomous vehicle or a diagnostic tool, its design choices can directly impact human lives. That's why ethical oversight must begin at the silicon level. Bias baked into hardware can amplify systemic inequities, and opaque design processes can erode trust in intelligent technologies. We're entering an era where chip architecture isn't just about performance, it's about accountability. Sustainability adds another layer of complexity. The semiconductor supply chain depends on rare earth minerals, high-energy fabrication, and global logistics, all of which carry environmental and geopolitical risks. As demand for application-specific semiconductors surges, so does the pressure to address e-waste, ethical sourcing, and lifecycle transparency. Leaders must embrace trust, risk, and security management, not just as a compliance framework, but as a strategic imperative. That means designing chips with recyclability in mind, securing data at the hardware level, and building cross-sector coalitions to govern responsible innovation. In short, the future of intelligent systems depends not just on what chips can do, but on how we choose to build them. Why this matters. Application-specific semiconductors aren't just technical marvels, they're strategic instruments of legacy. These chips represent a shift from generic capability to intentional design, where every transistor serves a purpose aligned with mission-critical outcomes. That matters because it mirrors the evolution of leadership itself, moving from broad ambition to focused impact. In industries like infrastructure, healthcare, and energy, application-specific semiconductors are enabling smarter systems, faster decisions, and more resilient operations. They're not just powering devices, they're shaping the future of how we build, protect, and sustain. For educators, strategists, and technical communicators, this is a moment to lead with clarity. Application-specific semiconductors demand cross-disciplinary fluency, where engineering meets ethics and performance meets purpose. They challenge us to think not just about what technology can do, but why it should do it. As we architect the next generation of intelligent systems, we must ask, are we designing for speed alone or for stewardship? Legacy isn't built on disruption, it's built on direction. And these chips, silent as they may be, are guiding that direction with every line of silicon. The next circuit. As we close today's episode, let's consider this. Every circuit tells a story. And the next circuit, the one etched into tomorrow's semiconductors, won't just power devices. It will shape decisions, define industries, and reflect the values we embed into our technologies. Application-specific semiconductors are more than tools. They're strategic expressions of purpose. Whether it's accelerating AI, safeguarding infrastructure, or enabling life-saving diagnostics, these chips are becoming the silent architects of transformation. So what's your next circuit? Is it a partnership that redefines performance? A policy that secures ethical sourcing? a curriculum that prepares the next generation of silicon strategists. Whatever it is, this is the moment to lead with clarity and build with intention. If today's episode sparked ideas or questions, I invite you to share them with the podcast. Thank you for joining the digital revolution in unraveling this fascinating topic. Be sure to stay tuned for more episodes where we dive deep into the latest innovations and challenges in the digital world. Until next time, keep questioning, keep learning, and keep revolutionizing the digital world. And with that, I appreciate your continued support and engagement with the Digital Revolution podcast. Stay tuned for more insightful episodes where we talk about the latest trends and innovations in intelligent technologies. Until next time, keep exploring the frontiers of intelligent technology. Don't forget to follow this podcast series to stay up to date on the ever-changing world of digital transformation. Thank you for supporting the revolution.